On this question, we want to find the limit as x approaches 2 plus of f of x. And we can see f of x here is defined to be a piecewise defined function. That's negative x if x is less than or equal to 2, x squared if x is greater than 2. So the first thing I want to notice here is where my limit is approaching. This limit has x approaching 2 plus. And that means that we are approaching 2 from above 2 or more than 2. And that's helpful because of this piecewise defined function. We have two equations, and the first equation is only used when x is less than or equal to 2, and the second equation is only used when x is greater than 2. So since our limit is approaching 2 from above 2, we're going to use the second equation to find our limit. So I can just use direct substitution, and I'll use that equation x squared and substitute 2 into x squared to get 4. So we've got our limit as x approaches 2 plus of f of x being 4. On this question, we want to find the derivative of the function f of x equals x times 2x minus 5 cubed. So when we're finding the derivative, we first want to take a look at our function and decide what rules we're going to be using when we do our calculation. So one thing I'm noticing here is that I have multiplication. I have x times 2x minus 5 cubed. So I'm going to have to use the product rule when I'm calculating this because I have one factor that has an x in it multiplied by another factor that has an x in it. So I'm going to use the product rule. And the product rule says this: if we're calculating the derivative of a function f times g, so a function that has a product, then we do the first function times the derivative of the second function plus the second function times the derivative of the first function. So that's the product rule that we're going to use. And then if I look within each individual factor, I'm going to have to take the derivative of x. That's simple. The derivative of x is 1. But I'm also going to have to take a derivative of the second function here, the second factor. And this has a power attached to something other than x. And so I know I'm going to have to use the chain rule when I'm calculating the derivative of that portion. So let's take a look at what the chain rule looks like. So when you are calculating the derivative using the chain rule, that's for when you have one function inside of another function. So for this example, the inside part, 2x minus 5, is like the g, and then the outside part is this cube, and that is like f. So the chain rule is used when you have a composition of functions, one function inside of another function. So the rule that we follow for the chain rule is that you are going to calculate the derivative on the outside function. You're going to leave the inside alone, leave it the same, but then you're going to multiply by the derivative of the inside, and that's the part that we call the chaining. You're chaining or multiplying by the derivative of the inside. So these are the rules that I'm going to use when calculating this derivative. Now I'm going to use the product rule first. Let's rewrite this function. I've made it a little bit messy there. We have x times 2x minus 5 cubed. I'm going to use the product rule first because it is sort of multiplication would be the last operation that we would do in this expression. You would calculate this whole thing here, calculate this whole thing here, and then multiply your final answer. So since multiplying is the last thing related to order of operations, it's the first rule that I use to calculate this derivative. So calculating the derivative, I'm starting with that product rule. So I'm going to do the first factor of x times 2x minus 5 cubed. We want to calculate the derivative of that. The first factor times the derivative of the second factor plus the second factor, 2x minus 5 cubed times the derivative of the first factor. And I need to calculate this derivative here. And to calculate that derivative, I'm going to use the chain rule. So using the chain rule, I'm going to start by calculating the derivative on this outside function, that's the cube. And that cube is a power. We're going to use the power rule to calculate the derivative. And should I write that power rule down? The power rule says you have the derivative of x to a power, that's the power, times x to 1 less than that power. So with the power rule, I'm going to make that power a coefficient, so multiply by the power. Then I'm going to take 1 away from the power, so 3 becomes 2. And that's using the power rule. So I've just done this part only, calculated the derivative of the outside function. And I want to now leave the inside function the same. So I'm going to copy this 2x minus 5, that's our inside function. So it stays the same. And the last thing for the chain rule is to multiply by the derivative of the inside. So I'm going to multiply by the derivative of 2x minus 5. And the derivative of 2x minus 5 is 2. So I calculated the derivative using the chain rule there. And I'll carry this 2x minus 5 cubed down. The derivative of x is 1. So at this point, I've calculated the derivative. I do have the derivative here. It's just a little bit messy. So I'm going to do a little bit of cleaning up. And let's see, x times 3 times 2, that would give me a 6x times 2x minus 5 cubed plus 2x minus 5 cubed. And I just made a mistake there. I changed 2 to 3, so let's correct that. That 3 should be a 2. And to clean this up a little bit more, I can put it in factored form. I have a common factor. This 2x minus 5 is a common factor. I'm going to factor out 2x minus 5, and I'll use the lower power to factor it out. So when I factor that out, the 2x minus 5 squared is gone, only 6x is left. And out of the second factor, I'm only taking 2 of these, so only 1 of them is left. So 2x minus 5 is left there. In the parentheses, I have some like terms I can combine. 6x plus 2x is 8x. Carry down that minus 5. So I've calculated the derivative of this function to be 2x minus 5 squared times 8x minus 5. For this question, we want to find the slope of the graph at the given point. We're given the function f of theta equals 4 sine theta minus theta, and we're given the point 0, 0. So in order to find the slope of the graph at this particular point, we need the derivative. So I'm going to calculate the derivative of f of theta. 4 is a constant multiple, so I'll carry that constant down. Then I need to calculate the derivative of sine theta, and the derivative of sine theta is cosine theta, and the derivative of theta is 1. Once we calculate the derivative, then we're going to evaluate the derivative at the point that was given. Now the derivative is the slope. So when we calculate the derivative, that's actually telling us the slope of the graph at every single point. We just want to know the slope at this particular point. So I'm going to substitute a 0 in for theta, and that gives me 4 cosine theta minus 1. Excuse me, I should have been substituting a 0 in there. Cosine of 0. So 4 cosine of 0. So I'm thinking of my unit circle, and I need the point on the unit circle that has an angle of 0. This point on the unit circle would be the point 1, 0. And cosine is the x-coordinate, so cosine of an angle of 0 is 1. So this is 4 times 1 minus 1, and 4 times 1 is 4. 4 minus 1 is 3. So we get that the slope at the point 0, 0 is 3. Thank you for checking out my videos. Have a great day.